everyone. So we're going to go ahead and use z-score formulas to be able to compare two scores to one another, understand percentiles using our normal curve distribution, and then also compare percentiles to kind of make comparisons between two data sets. In this specific example, we're going to compare exam grades. So you and a friend, you guys are in two stats classes, for example, but two different stats classes. And you had exam one and you scored a certain way, your friend scored a certain way. You want to look at who did better comparatively to each other's sampler population, right? So while, you could compare your score to your friend's score, it wouldn't necessarily be an equal comparison because their professor might be teaching the class very differently. The average grades across his or hers entire class could be very different, right? So we can use z-scores to be able to standardize our scores and then to come up with percentiles to help make accurate comparisons. So how do we do this? So here's our example. So you earned 85 out of 100 on an exam. The mean in your class was 67. The standard deviation in your class was 12. Your friend, on the other hand, earned 7.5 out of 10 on an exam in his class. The mean in his class was 5.9, and the standard deviation in his class was 0.8. With all these numbers, who did better? So if you were to look at your percentile for, or your grade for the exam, it was an 85 out of 100. Your friend, on the other hand, scored a 7.5 out of 10, which is equivalent to 75, right? So off the bat, you would be like, oh, I did better because I have an 85 and that's bigger than 75. But like I said, this is not a fair comparison because you guys are in two different classes and two different population sets, right? So we want to standardize these scores. So first, let's find a z-score for you. So your individual score is 85. The population or the mean in your class was 67, so that would be our mu. Our standard deviation is 12. So to pump out our z-score, you want to do equals, open parentheses, your x minus the mu, close parentheses, and then divide that by your standard deviation. Okay, so you get a z-score of about 1.5. Your friend, on the other hand, their x-score was 7.5. Their class mean was 5.9 and their standard deviation was 0.8. So same formula, your x minus your mu, open parentheses, divided by your standard deviation. Okay. So now we have a z-score of 1.5 for you and a z-score of 2 for your friend. We still can't make a really good comparison yet, but we can if we convert them to our percentiles. So the orange line here is going to represent you and the blue line here is going to represent your friend. So 1.5 in our normal distribution curve here would probably likely fall somewhere here, right? Then 2 for your friend would fall on the 2. Okay, so let's do your friend's percentile first because that is easier. It's actually falling right at that line. So to do the percentile, you just want to add your percentages up until the point where you come to that line. So you want to add 2%, 14%, 34%, plus 34% plus 14%, right? And you should get roughly 98% for your friend's percentile score. Or you could have also done 100 minus 2 because the 2% is at the end tail here. But essentially, we're looking at 98% for your friend. You, on the other hand, you're over here. You're not necessarily at the 1, you're not necessarily at 2, you're at 1.5. So if we get up until the 0, we know that that's already 50%, right? Because it's 2 plus 14 plus 34, 50%. We can also add this additional 34% because we're up until the 1 still. So 50 plus 34% is 84%, okay? But now we can't add this whole 14% because the line cuts off in the middle. So because it's in the middle of 14, we can assume that up until 1.5, we have 7%, right? About 7%. So what you would do in this case is add that 84%, which is all of this together, to the 7%. And you would get roughly 91%. So to make a comparison of this, you would say that you fell in the 91 percentile in your class, and your friend fell in the 98 percentile in their class, right? So if we were discussing, well, who performed better on the percentiles case, we would say that your friend performed better. Okay? So this is how you would use z-scores and percentiles and your normal curves to be able to make comparisons while standardizing our scores.